Hi, this is question 46. We are going to discuss our problems in definite integrals. And this question talks about evaluating this limit. So again, this is not very difficult. You have to think about this as L'Hopital's rule and application. So t square cos power 5t dt divided by x cube x minus sine x, right? This is the limit that we have to find, limit x tends to 0. So obviously this is 0 by 0 form. So because this integral will vanish at when x tends to 0. So we can differentiate the top part as well as the denominator. So that limit will be equal to just, how do you differentiate the numerator? You put x square, the upper limit in this function, and then differentiate the upper limit, and then subtract by putting the lower limit in the function and differentiating the lower limit. Lower limit is a constant, so the differential coefficient of the constant is 0. You don't have to do any subtraction here, but you have to put x square in place of t everywhere. This will become x power 4 cos power 5 x square, and differentiation of x square is 2x divided by this expression is basically x power 4, so differentiation is 4x cube minus x cube sine x, so minus 3x square sine x minus x cube cos x, right? So this is the expression that we have. So clearly we can cancel an x square up and down, and this will become x square into 2x. So this is 2x cube cos power 5 x square divided by, and we can say 4x minus 3 sine x minus x cos x, right? This is the expression here. Now, if I have to evaluate this, the best way to do it would be to utilize Taylor series expansions, right? So think about this. We have here, but before we do Taylor series, let's simplify it a little more, because we can say limit x tends to 0, 2x cube cos power 5 x square divided by 4x is equal to 3x plus x. So we can write x 1 minus cos x plus 3x, so 3x minus sine x, right? So this is the expression here. And now maybe you can put in the Taylor series. Taylor series basically for cos x is 1 minus x square by 2 factorial plus x power 4 by 4 factorial and so on. And for sine x is x minus x cube by 3 factorial plus x power 5 by 5 factorial and so on. Once you put the Taylor series expansions, you should get the answer of this limit. It will turn out to be 2. Okay. Just check the calculations once in case we have made any mistakes. Should come out to be 2. So this is question number 46. The next problem that we'll look at is 47. And this question, let me just write it down for you. Uh, yeah. So we have, if I is equal to integral from 0 to t root over 1 plus root x by 1 minus root x dx, and j is equal to integral 0 to 1 root over 1 minus root x by 1 plus root x dx, right? Then we have to find out the value of I plus j, I minus j and stuff, right? You have to find out I plus j, I minus j. So how do we go about doing this? So let's think about it. If I'd have to do I plus j, let's just evaluate the sum of these two expressions, right? Forget about the integral for now. Actually, this is also 0 to 1. It's not 0 to t. It's 0 to 1 and this is 0 to 1. What is the sum of these two algebraic expressions? So you should have root over 1 minus root x into 1 plus root x. So that is 1 minus x and then multiplication of this root and this root. So that will be 1 plus root x plus multiplication of this with this. So that will be 1 minus root x. So you end up getting 2 by root over 1 minus x, right? Now evaluating this integral is actually not so hard. 2 by root over 1 minus x, you should put x is equal to sine square theta, and what you will get is dx is equal to 2 sine theta cos theta d theta, and you will get 2 into 2 sine theta cos theta d theta divided by 1 minus sine square cos theta. This cancels and you have 4 sine theta d theta. 4 sine theta d theta. Now what is the limits for theta? When x is 1, theta should be pi by 2. When x is 0, it should be 0. So this will come out to be minus 4 cos theta from pi by 2 to 0. So that will be 4, right? So I plus j turns out to be 4. In a similar manner, you can find I minus j also. Just evaluate the expression. You will end up getting the integral of 2 root x by root over 1 minus x, right? Again, the substitution x is equal to sine square theta will work, and you can do the rest yourself. Your answer for I minus j should come out to be pi. Check that out for yourself. It should come as pi. The next one that we will look at now is question number 48. And this question talks about finding the value of this particular integral. Minus pi to pi cos 2x cos 2 square x cos 2 cube x and so on. Actually just 5 terms, 2 power 4x and cos 2 power 5x dx. This is the integral that we have to evaluate, right? Now it is minus pi to pi and cos is an even function. Therefore, this can be written as 2 times 0 to pi, the same expression. Cos 2x, cos 4x, and so on till cos of 32x, right? Okay. Now, this is my expression 2, 0 to pi, cos 2x, cos 4x, cos 32x dx. Now, what happens if we put f of pi minus x instead of f of x, right? We can see clearly that it will be cos of 2 pi minus 2x, which is equal to cos 2x. And cos of 4 pi minus 2x, everything will be same. Cos of 4 pi minus 4x will be equal to cos of 4x, right? So there is no change that happens in this, and this is equal to f of x, right? So therefore, we can say that instead of integrating from 0 to 2a, let's call pi is equal to 2a. I will integrate from 2 times. This will be from 0 to pi by 2, right? And the whole thing is that uh, we can just convert this integral into double of this 0 to pi by 2 integral. So there's an extra 2, and this is the same integral, right? We have this situation right now, correct? Your integral is equal to 4 times I is equal to 4 times 0 to pi by 2 f of x dx. F of x dx, where f of x is equal to cos 2x, cos 4x, and so on till cos 32x. Now you will realize here that this is equal to 4 times the original function. No, this was the function. No, I was this thing. So 2 times this thing, correct? 4 times this thing. And let's call this integral individual integral cos 2x cos 32x as I1. This is I1, let's say. Now we have to find out 4I1, right? Okay. Uh, we should be able to prove that I1 should be 0. This is the expression that we have. And if I use pi by 2 minus 2x, a plus b minus x property again here, that doesn't seem like it will do much. Yeah, so what we are getting is I is equal to, the original integral is equal to 4 times f of x. And f of x looks like this portion, looks like I itself actually, correct? So it feels like this is I is equal to 4I sort of thing is coming. So I must be 0. Or I'm unsure about this. Another way for it, there is a long way to do it, but I just don't want to do that. You can combine cos 2x, cos 32x and stuff. Cos 4x and cos 16x. And you'll keep cos 8x in the middle. I just don't want to do that simplification. You can try that, however. You should eventually get I is equal to 0. I have a feeling like I made some mistakes here in this calculation. But you can try out this particular option. You can just group the 2x with the 32x and 4x with the cos 8x, right? 4x with the 16x actually. Cos 8x is alone, right? So this is what we get. We should get the answer 0 in this particular question. Let's look at another one, question number 49. In this one, we talk about some properties of definite integrals which are useful from a JEE advanced perspective. Like there is a paragraph question here. Let gx be a differentiable function satisfying the gx is a function that satisfies this equation integral of 0 to x minus t plus 1 gt dt is equal to x square plus x power 4 if what is also given is that h of x is equal to gx plus g dash x and f of n basically is equal to h of n plus 1 minus h of n, right? So this is additional information that is given to us, right? So first thing to find out is 0 to 1 g double dash x dx, right? So this is what we obtained. Okay, so we'll not worry about this right now. We'll look at this condition. And since it's an integral over t, I can say 0 to x gt plus uh, this is 0 to x 1 minus t g of t dt, right? I've split it into two parts, is equal to x square plus x power 4, because the dependency on x was only on the t variable. There's a t variable that we need to care about. Here x will go out of this integral and it will be 0 to x g of t dt plus 0 to x 1 minus t gt dt, right? So if I differentiate both sides of the expression, what I will get is x g of x. Uh, I'm differentiating both sides of the equation. X g of x makes sense, minus g of 0 will be 1. So 0 to x dt dt. Correct. We are getting this, nothing else here, minus 0, plus 1 minus x g of x is equal to 2x plus 4x cube, right? So notice that xgx and this xgx cancel. So what is left with gx is equal to 2x plus 4x cube. Then obviously g dash x is equal to 2 plus 12x square. So these are the values of your g derivatives, right? So 0 to 1 g dash x, g double dash x will be equal to integral 24x 0 to 1 dx. So that will make correct. 24x double derivative, yeah. And the value now we are getting is 24 into x square, so 12x square 0 to 1 is equal to 12, right? We have found one of the integrals, which is, and we have also found our gx, by the way. So gx has come out to be 4x cube plus 2x, right? So obviously you'll find everything else. So this was question number 49. Let's look at question number 50. Okay. Let f be a function such that f of x is equal to ln by 9, x belongs to 0 to 2, and here it is 0 to 1, 2 by 2t minus x mod plus 3 dt, x belongs to 2 to 4, right? Okay, now we'll start off by trying to find out the minimum value of fx in 0 to 4. So in order to do that, I have to define my f of x properly, right? 0 to 4 I'm trying to find. So this fx is becoming ln x plus 3. Yeah, I've made a mistake in framing it. It's like this, x plus 3 by 9 from x belongs to 0 to 2 and 0 to 1. This is 2 by 2t minus x plus 3. Now you have to realize here that this is the integral over dt, right? So dt integral means 2t will range from 0 to 2, and x here, x belongs to 2 to 4, right? So 2t is always smaller than this. So we should always have 2 by x minus 2t plus 3, right? From 0 to 1, correct? So that is something that you need to realize here. So this integral dt will just come out to be ln, by the way, ln of 3 plus x minus 2t by minus 2, right? And correct that value, and then 0 to 1 you will do, right? So your fx will come as equal to ln of 3 plus 1, 4 minus 2t by minus 2 minus minus, so plus ln 3 minus 2t by 2, right? Once you have your fx, it's a matter of differentiating both the functions, right? The only thing that I wanted to point out here is that you have to break the modulus sign by taking care of which one is larger, right? Which one is larger is important because dt is the variable, and the variable can go from 0 to 1. So 2t can go from 0 to 2. However, x is supposed to lie between 2 to 4. So this doesn't match, right? You have to write it like this, x minus 2t plus 3, because in this range, 2t minus x is actually negative. Once you do this, your integral will become a simple log integral. So that part is easy. And your function here is a log here, and here also we are getting a log function. Once you get two log functions, more or less you can confirm that the function should be, in general, increasing in certain domains. So you can find out that by doing the derivatives. It's just long work from this point. So I will just stop here, and I will not add the solution exactly to this particular question. What we'll see in the next few videos are a few more problems, and then we'll end the problem portion of the course. We'll probably look at some of the higher advanced level techniques that integrals have to offer, and uh, hopefully you'll learn a lot from those videos which come after we do the traditional questions for this particular chapter. See you in the next video.